The most significant global environmental problem faced by the world community is related to global environmental changes consequent upon the global warming, resulting from a host of causal factors, mainly anthropogenic factors, such as changes in the atmospheric chemistry, ozone depletion, emission of the greenhouse gases at alarming increasing rate, urbanization, land use changes, mainly deforestation, etc. The probable net result of the global warming and changes in the atmospheric chemistry through air pollution and other natural sources would be climatic changes, also discussed in the previous chapter, at local, regional and global levels, including both short-term and long-term changes in the weather and climate. You will be able to understand the ozone depletion, greenhouse gas effect, etc. The international communities are scared of catastrophic adverse effects of future climate changes on different spheres of man and nature. For example, deglaciation and sea level changes, submergence of the island nations and major coastal lowlands, atmospheric dynamics including evaporation and precipitation, global radiation balance, photosynthesis and ecological productivity, plant and animal community, human health and wealth, and many more. The major sources of the global environmental problems have been identified as changes in the atmospheric chemistry through air pollution, both gaseous and solid particulates pollution through rapid rate of industrialization and urbanization, population growth at an alarming rate, advances in the productive technology, major land use changes, mainly deforestation, etc., and efforts are afoot for tackling the problem of global warming changes leading to climatic changes at international level. It is thus necessary to discuss the evidences of global warming, trend of global warming process of global warming, including ozone depletion and emission of greenhouse gases, effects of global warming, air pollution leading to changes in the atmospheric chemistry, and related environmental problems and international cooperations to tackle the problems of global warming and climatic changes. Global warming refers to gradual rise in the atmospheric and ground surface air temperatures and consequent changes in the global radiation balance caused mainly by anthropogenic processes. Although natural processes also cause global warming and cooling, leading to climatic changes at different levels, for example, local, regional and global levels. It may be pointed out that the pattern of global rise in the air temperatures has been studied and reported by different scientists and agencies, and a few computer models have been constructed, but their results are not uniform. Rather, a few are contrasting. The radiative forcing and global warming potential are used by the Intergovernmental Panel on Climate Change to compare the relative warming effect of gases. The following evidences support the theory of gradual rise in the air temperature and consequent global warming. Temperature records, melting of the mountain and continental glaciers, warming of the ocean water at global level, rise in the sea level, thawing of the permafrost areas, upward shifting of the snow lines of tropical and subtropical mountains, spreading of tropical diseases towards temperate and polar regions, shifting of the seasonal weather phenomena, and changes in the precipitation patterns, etc. It has been stated that overall increase in the air temperature in the 20th century has been about 0.5 to 0.7 degrees Celsius. The last century, that is the 20th century, has been the warmest century in the last 2000 years. The last 2 decades of the 20th century, that is 1980s and 1990s, have been warmest decades since the systematic recording of air temperature, which began in 1880. All the 10 warmest years have recorded since 1980. The last decade of the 20th century, which is the 1990s, was the warmest single decade in the historical record of temperature, as 7 out of 10 warmest years occurred in the decade wherein the year 1998 was the warmest year of the millennium. According to another view, the average air temperature in the northern hemisphere increased by 0.4 degrees Celsius between 1880 and 1940 because of the rapid rise of the combustion of fossil fuels during the period. But the temperature dropped after 1950 in spite of the continued rapid rate of combustion of the fossil fuels due to fast industrial growth. Soon after 1940, the air temperature in the southern hemisphere showed rising trend, which registered an overall increase of 0.6 degrees Celsius between 1940 and 1960. Another source has indicated an increase in the air temperature by 1.5 degrees Celsius up to 1995, while other sources have shown general air temperature rise ranging between 0.3 degrees Celsius and 0.6 degrees Celsius. It may be mentioned that a rise of 2 degrees Celsius temperature from the normal temperature was recorded in the Indian Ocean during 1997 to 1998, which caused catastrophic coral bleaching, leading to 70% death of the corals in the Andaman Nicobar and the 𝗪𝗓𝗃 Islands. Various models have been developed to predict global rise in the air temperature. 𝗧𝗦𝗔𝗧 1950 pointed out that the temperature could rise up to 1.5 degrees Celsius to 3 degrees Celsius if the concentration of the atmospheric carbon dioxide could be doubled from the 300 parts per million level to 600 parts per million level. The general circulation model developed by 𝗧𝗦𝗔𝗧 and 𝗪𝗏𝗏𝗏 in 1975 predicts that if the present, that is the 1975 level amount of carbon dioxide of the atmosphere is doubled, then the temperature of the Earth's surface will increase by 2.9 degrees Celsius. The global circulation models have shown a temperature rise between 0.4 degrees Celsius to 0.8 degrees Celsius in the 20th century and have predicted warming of high latitudinal zones, mainly the Arctic regions. The early melting of the winter snow in the Great Britain, Norway, Canada, the United States, etc. has resulted in early beginning of the spring season at least by 15 days, as evidenced by flowering of the plants of spring season in 2 weeks in advance. The flowering of the mango trees in Uttar Pradesh in India in December also indicates warming trend. The temperature records a few American and European countries that have shown that the diurnal range of temperature, or say difference of temperatures between days and nights, has been reduced. The increase in the frequency of El Nino events between 1970 and 2080 also denote the warming of the Earth's surface and its atmosphere. On the basis of the aforesaid trend of the temperatures in the past century, it may be said that the rising trend of temperatures denotes global warming. It is argued by some scientists that the temperature data are deceptive and confusing because most of the temperatures have been recorded in the urban areas, which become locally warmer than the surrounding countryside because of urban population, and we lack insufficient temperature data from ocean surfaces, so nothing precisely could be said about either global warming or global cooling. The recent evidences have shown that the ice sheets of Antarctica and Greenland are breaking. The permanent ice covers of the Arctic regions are melting, and the continental and the mountain glaciers are sinking in both size and length, as evidenced by their regular retreat. It may be mentioned that the Antarctica is well instrumented continent in terms of the study of various aspects of the continent. For example, surface and air temperature, ice core analysis, size and thickness of the ice sheets and glaciers, contraction and shrinking rate of the ice sheets, etc. The regular monitoring of the Antarctic ice sheets has shown about 100-meter annual rate of their shrinking. A rise of temperature of winter season by 4 degrees Celsius has been reported since 1950 in the West Antarctic Peninsula. There are ample evidences to demonstrate regular breaking of the ice shelves and formation of giant icebergs, which are floating masses of ice. It may be mentioned that the ice shelf is floating huge mass of ice, but it is attached to the land mass, while icebergs are floating masses of ice independent of the ice shelves. In other words, the icebergs are formed when the ice shells are disintegrated. Thus, huge volumes of mass of ice known as iceberg, measuring several hundred square kilometers in the area, floats independently in the sea. It is significant to point out that melting of the icebergs does not make any change in the sea level because these have already occupied places in the sea, but melting of the ice shells and glaciers cause rise in the sea level. The disintegration of the Antarctic ice shells is rapidly increasing. For example, the Larsen ice shelf disintegrated in 1995, while many Arctic ice shelves including Larsen B and Wilkes ice shelves broke away during the 1998 to 1999. Recording of ice covers over the Bering Sea and the Arctic Sea has revealed gradual but regular shrinking of the areas. For example, there has been decrease in the aerial coverage of the Bering Sea ice covers by 5% since 1960. The sea ice over the Arctic Sea has decreased by about 90 square kilometers since 1978, etc. There are ample evidences to demonstrate the melting and retreat of mountain glaciers, for example, Alpine, Himalayan and the Andean glaciers, etc. A few examples would be sufficient to enough validate the melting and the retreat of the mountain glaciers upward. The European alpine glaciers have been reported to have shrunk in their length and volume by more than 50% in the past century. The rate of the upward retreat of the Andean glaciers in the Peru increased 7 times in the last 3 decades of the 20th century, more precisely between 1978 and 2000 AD. The Russian Caucasus Mountains glaciers have been shortened in their length by about 50% due to melting since 1960. The glaciers of Chinese Tian Shan Mountains have lost their ice volume by 20% on the melting since 1960. The glaciers of the Chinese Tian Shan Mountains have lost their ice volume by 25% on melting since 1960. The glaciers of the Southern Alps of the New Zealand have moved upward by about 100 meters due to their retreat caused by the thermal melting of ice. Mount Kenya has lost its most extensive glacier in the past century, etc. The gradual spread of a few tropical and subtropical diseases poleward, such as malaria, cholera, plague, dengue fever, yellow fever, etc., is indicative of the global warming. It may be mentioned that the insects, bacteria, viruses of such diseases flourish in extreme weather conditions. For example, extreme heat and cold, extreme wet and dry seasons. The global warming is supposed to bring extreme weather conditions in the middle and the high latitudes. In the cases of outbreaks of cholera in 1991 in Peru, dengue fever, for example, during 1994 in Australia, and malaria in the temperate countries demonstrates the warming of the middle latitude areas. According to an estimate, presently tropical diseases cover about 42% area of the globe, which may increase to 60% if the average Earth's surface temperature rises by 2 degrees Celsius. Decrease in the Antarctic penguins population by 40% during the past 3 decades of the 20th century due to their deaths from the starvation because of rise in the sea temperature causes marked decrease in the zooplanktons, which are main sources of penguin feeding, is indicative of the global warming. Mass destruction of the corals due to the coral bleaching is another significant indicator of the global warming. The coral bleaching during 1997 to 1998 has been recorded as the most catastrophic event as it accounted for large-scale deaths of corals in the tropical oceans of 60 countries and island nations. Though coral bleaching was observed by Alfred Mayer as back as 1991, but it was the year 1998 when large-scale coral bleaching accounting for 70% deaths of the corals off the coast of Kenya, Maldives, Andaman and Nicobar Islands and Lakshadweep Islands in the Indian Ocean, and 75% deaths in the Seychelles Marine Park System and the Mafia Marine Plant of Tanzania was reported by Clive Wilkinson of the Global Coral Reef Monitoring Network of the Townsville, Australia. The analysis of the recorded temperatures at the sea surface and below up to the depths ranging between 800 meters and 3000 meters has revealed the fact that the average sea temperature has risen by 0.6 degrees Celsius in the later half of the 20th century, which caused rise in the sea level by 10 to 25 centimeters. It has been estimated that if the current rate of increase of the sea temperature continues up to the end of the present century, that is by 2100 years, the sea level would register an increase of 1 meter. Major sources and processes of global warming include ozone depletion and greenhouse effects. Thus, it is necessary to understand the mechanism of creation, destruction and maintenance of the ozone layer and the sources and processes of intensification of the greenhouse effects by increasing emission of carbon dioxide and methane for the evaluation of global warming. The mechanism of ozone depletion includes the aspects of creation of ozone, destruction of ozone and recreation or maintenance of the ozone layer in the stratosphere. It is desirable to understand the mechanism of the formation of the ozone layer first, so that the processes of the destruction and its impacts on the global warming can be properly understood. It may be mentioned that the thinning of the stratospheric ozone layer allows more ultraviolet solar radiation to reach the Earth's surface and thereby increases the temperature of the Earth's surface. The stratospheric ozone layer, mostly concentrated between the altitudes of 12 kilometers to 35 kilometers, is considered as a protective shield and Earth's umbrella because it prevents ultraviolet solar radiation from reaching the Earth's surface. The presence of ozone layer in the stratosphere is of vital significance for all biota, including plants, animals and man in the biosphere. In the absence of this layer, no life is possible in the biosphere because all the ultraviolet rays of the sun will reach the Earth's surface and consequently the temperature of the Earth's surface in the lower atmosphere will rise to such an extent that the biological furnace of the biosphere will turn into a blast furnace. Ozone, defined as a 3-atom isotope, one of the set of chemically identified species of atoms that have the same atomic number but different atomic weight, is called the isotope of oxygen, that is 03, or merely a triatomic form of oxygen, is a fairly blue irritating gas with a characteristic pungent odor. Ozone is a strong oxidizing agent which can at high concentrations decompose with an explosion. It may be pointed out that the ozone is present almost at all the altitudes in the atmosphere, but the bulk of its concentration is present in the layer from 10 kilometers to 50 kilometers up in the atmosphere, and within this zone or ozone, the highest concentration of ozone is between the altitudes of 12 kilometers and 35 kilometers in the stratosphere. This zone of 12 to 35 kilometers of ozone is called the ozonosphere or the ozone layer of the stratospheric ozone layer. The ozone gas is unstable because it is created as well as destroyed or disintegrated. In other words, the creation and destruction of the ozone gas is a gradual and continuous natural process. The formation of the ozone due to the collision of 3 atoms through the process of photochemical reaction triggered by the sunlight is more active in the atmospheric zone of 30 to 60 kilometers height from the sea level. It is further important to note that the ozone mixing ratio, which is the mass of ozone per unit mass of the dry air, is maximum at the height of about 35 kilometers, but the maximum ozone density, which is the mass of ozone per unit volume, is found between the height of 20 to 25 kilometers. Though ozone layer contributes only about 3 to 4 mm of the thickness to the total atmospheric thickness of 8 meters, if the whole of the atmosphere may be compressed to sea level temperature and pressure, but this layer is a life-saving protective cover for all the biota of the biosphere. There has been much hue and cry about the depletion of the stratospheric ozone in the last 1 or 2 decades of the 20th century, and the issue has now assumed a global dimension because the problem of ozone depletion and its adverse consequences have threatened the existence of all forms of life in the biosphere. The presence of ozone layer in the atmosphere is very crucial and significant for plants and animals in general and human beings in particular because it provides protective cover known as the Earth's umbrella to all the organisms including plants, animals, microorganisms and man in the biospheric ecosystem against their exposure to ultraviolet solar radiation. In fact, the ozone layer filters the solar radiation by absorbing unwanted ultraviolet rays and allowing only those radiation waves to reach the Earth's surface which are essential for the maintenance of life of the planet Earth. A greenhouse is meant for plants mainly in the cold countries where total insulation, at least during winter season, is not sufficient for the support of plant growth. The glasses of the greenhouse are such that these allow the visible sunlight to enter but prevent the long wave infrared rays to go out. A greenhouse also does not have any provision for artificial heating. The greenhouse effect means progressive warming up of the surface of the Earth's surface due to the blanketing effect of man-made carbon dioxide in the atmosphere. In a greenhouse, visible sunlight passes through the glass and heats up the soil and warms the plants. The warm soils emit radiation in longer wavelengths, particularly in the infrared. Because the glass is opaque to these wavelengths, that is the long wavelengths of the infrared waves, it absorbs and reflects the infrared radiation waves. This mechanism keeps the greenhouse warmer than the outside environment. In a nutshell, it may be summarized that the greenhouse is a body which allows the short wave incoming solar radiation to come in but does not allow the long wave outgoing terrestrial infrared radiation to escape. Carbon dioxide and water vapor act as greenhouse in that these allow visible light of the sun to reach the surface of the earth but absorb and reflect back the long wave outgoing terrestrial radiation, mainly infrared rays, back to the earth's surface and thus help in keeping the earth's surface warmer. The gases with the properties of greenhouse are called the greenhouse gases such as carbon dioxide. Elongated gases such as chlorofluorocarbons are also greenhouse gases because these absorb long wave terrestrial radiation in the 8 to 13 microns band and thus help in enhancing the carbon dioxide greenhouse gas effect. It may be thus concluded that the net result of the greenhouse effect of the carbon dioxide, water vapor and halogenated gases is the increase in the temperature of the Earth's surface and the lower atmosphere because these gases allow solar radiation to reach the Earth's surface but absorb most of the long wave terrestrial radiation and re-radiate it back to the Earth and thus regularly warm the Earth's surface and its immediate atmosphere. The importance of reduction in the global warming was recognized and a concrete protocol called Kyoto Protocol in 1997, Montreal Protocol in 1987 was signed by the international community to address global warming and ozone depletion respectively. Many conventions and summits are organized every year to reduce the climate change, biodiversity conservation under the heads of United Nations Framework Change on Climate Change, United Nations Convention on the Biodiversity, which are UNFCCC and UNCBD respectively. New Paris Deal on the Climate Change signed in 2015, which came into force in 2020, also seems promising.